Okay, so just make one correction in the properties of power set. Just make one correction. This is not equal to A union B is not equal to this. Power set we have not done for union, that's why. So it is not equal. Okay. The union is not equal. Other for intersection it is true. For union it is not true. To find we are doing union first. Okay. So find. I was taking one simple question for finding the union of two sets. To find the union of find the union of A A E I O U A E I O U and set B is A C D A C D. Okay. So A union B, how we will find? A union B is equal to the all elements right together. A, then B is not there, C is there, B is there, E is there, then I O U. Okay. So this is the union. So in union we are just adding the two sets. And one more question is on union, but that just I told you to make the correction. So the question is it true? Is it true that for any set A and B, A and B, power set of A union power set of B is equal to power set of A union B. Is it true? Justify your answer. Justify your answer. Means we have to prove. So we will take two sets and we will prove it. So let for solution A and B take two sets. Let A is the set of elements 1, 2 and B is the set of elements 2, 3. 2, 3. Okay. Then first find A union B. Then find A union B and A union B means add them. So 1 is there, 2 is there, 3 is there, A union B. Okay. Then find you can find here B A union B first, no problem. You can find power set of A union B. What will be the power set of A union B? 5, 1, 2, 3, then 1, 2, 2, 3, 1, 3, and 1, 2, 3. This is the power set of A union B. Now you can write the power set of A. Power set of A is 5. This set A 1, 2, and 1, 2. Then write power set of B. This is set B. Power set of B will be equal to null set, then 2, then 3, then 2, 3. Okay. Now we will see what is PA union. P A union B, union of the power set. Please add them. So 5 is there, 5 is there, 1 is here, so we will write here 1, 2, both sets, we will write one time. Then 1, 2 is not there, so we can write 1, 2 here because we are adding. This is done. Now 3 and 2, 3. This is the A union, power set of A union, power set of B. Now find the power set of A union, power set of A union, and A union B is this one. Its power set will have 8 elements, 2 to 2 raised to power 3. So 1, then 2 and 3 single element set, then double element set 1, 2, 2, 3, and 1, 1, 3, and 1, 3. Okay, and 1, 2, 3. So you can see now they are not equal. Why? Now you have to see, we observe that from first and second, from 1 to 3 is not there, so they are not equal. So because 1 to 3, from first and second, this is second. From first and second, you can see this element is not there, so they are not equal. Or and 1, 3 is also not there, so they have different element, they are not equal. So from first and second, we observe that union of power set is equal to power set of union are not equal. It's not equal to the power set of. Okay, so it's very simple. Now intersection of sets. That was the union. Now we have intersection of sets. So remember that is for union we use or, and for intersection we use and. It is very important when you study probability. It will play a very important role. So here intersection means and. For a definition, let A and B any two sets, A and B be any two sets, be any two sets. Okay. Then the intersection of the intersection of A and B is a set of all those elements, a set of all those elements, only common element here we will take. So all those elements which belongs to both A and B. Elements which belongs to means common element which belongs to A and B means which belongs to both A and B. Okay, and it is denoted by, I'm not writing, it is denoted by this A intersection B, and A intersection B is a set of all x such that x belongs to A and x belongs to B. If there is no common element, then its intersection will be a null set. How we will define intersection? That was the union. So, yes, in union, you have to draw the Venn diagram of union of two sets. How will you draw? You will make a universal set like this. Universal set, and A and B has two elements. If they have common elements, they must have common elements. So if they have common element, this is set A, and this is suppose set B. Then you have to show that A union B. This diagram is you have to show A union B means all the elements which are in A and B. So you have to fill both the parts, this part as well as the other part. Okay, you have to darken this set because all the elements of this set plus the element of this set added. So this will be the representation of union of two sets. Okay, got it? This is the representation of union of two sets. Similarly, for intersection of two sets, first I will take one example for intersection of two sets. Let A is a set of elements 1, 2, 3, 4, 5, and B is a set of elements 1, 3, 6, 4. Okay, so A intersection what will be the then A intersection B will be equal to common element. What are the common elements? 3 is there, 3 is there, common element. And what else is there? 4. 4 is there, 4 is there, 3 and 4, that's all. 1 is also there, sorry, 1 is also there. So 1 is common, 3 is common, and 4 is common. 1 is 1, 3, 4. Therefore, intersection will have like this. So if we want to draw this diagram, so intersection is always we have to fill or darken the common portion only. This you should write all previous question also I forgot to write. You can write. So A intersection B means you have the common portion, so you will draw A set, this set A, and this is your set B. Okay. Then you have set A. What are the common elements? 1, 3, 1, 3, and 4. You can draw 3 and 4. And it has 1, 3, 4. After that, 2 and 5 are left. 2 and 5 are here, and 1, 3, 4, 6 is here. But you are showing only A intersection B in this Venn diagram. The common portion should be shaded. Only shade the common portion. There you have to shade full portion. Here you have to shade only common portion. This common portion should be shaded. This is showing that it is A intersection B. So I think you can find out easily intersection of two sets, and now difference of two sets, and there are some properties of intersection and union, laws of union of two sets and laws of union of intersection of two sets. So laws of union of two sets, laws of union of two sets. Number one, for any three sets A and B we have, uh, for any three sets A, B, and C, we have number one law. First law says that if you find A union null set, if you add null set in any set, there will be no effect on the set. So you can write A union intersection, A union null set will be A. And universal set, if you will find the union of any set with universal set, it will remain a universal set. Okay. And this is called identity law. This is called identity law. Name is ident. First phi is identity set. Identity law for union, and this is called universal law for union. Universal law. And then third, if you find the union of the same set, A union A, it will remain A union. It is called idempotent law. Idempotent law. And the fourth is either you find A union B or B union A. First you take A union B, or you can take B union A. So this is commutative law because we are changing A plus B equal to C plus A. This is called commutative law. Then the last one is A union B. If you are finding A union B and then union C, or you find first A union B and then B union C and then union A, so it is called associative law. A plus C plus C or A plus B plus C. So it is called associative law. Similarly, for intersection, same name. I will write here the laws of intersection of two sets. Intersection of two sets. First law, this is first law, and its name is same name, identity law. For here intersection, if you will find A intersection null set, so it will be a null set. So this is called identity law. Then second law, name is same. Second law, universal set, intersection of universal set with any set A. Obviously, it will be A. And third law, that is third law, that is called idempotent law. A intersection A is A always. And fourth law, A intersection B, commutative law, A intersection B will be equal to B intersection A. And the fifth law is also applicable, associative law. A intersection B intersection C can be written as A intersection B intersection. And name is same. This is associative law. This is commutative law. This is idempotent law. This is universal law. The name are same. So this property is where union. This is the property of union and intersection. There is one property where union and intersection both can be used. That is called distributive law. So in distributive law, we will use both union and intersection together. The distribution of intersection over union and union over intersection, like we are doing A plus B into C. This is the distribution of plus over intersection A intersection B plus C. This is the distribution of product multiplication on addition. Similarly, if A and B are in two sets, if any three sets A, B, C are any any three sets, any three sets, then number one, intersection over union, A intersection B union C. A intersection B union C. This intersection will multiply inside, then it will become A intersection B. Intersection will go with B, then union will come in between, and A intersection B. This is the distribution of intersection distributes over union. Distribution of intersection over union. Intersection distribution of intersection over union. Now opposite, distribution of union over intersection B, intersection C. A union B, then intersection A union C. This is called union, distribution of union over intersection. Union over intersection. Okay. So we can have some type of questions there. We have to find or verify these laws. For example, we take questions for this one. So if A is a set of elements 4, 4, 5, 7, 8, 10, and B is a set of elements 4, 5, 9, 4, 5, 9, and C is a set of elements 1, 4, 6, 9. Then verify that. Then verify. So it is very simple to verify these properties. You know that. Verify that number one, A intersection B, A intersection B intersection C is equal to A intersection B intersection C. Second, A union distribution. A union B intersection C is equal to A union B intersection A union C, and distribution of intersection over union A intersection B union C is equal to A intersection B union A intersection C. Okay, so you want me to solve this question, so you can. So it's very simple question. I think no need to. So I can solve. How will you solve? First, you will find A intersection B. Okay, A intersection B. Find A intersection B. What is common between A and B? 4. 4 is common. 5. Okay, 5 is common. 7 is not there. 8 is not there. 10 is not there. Okay. Then you have to find with the intersection of this A intersection B with intersection C. C is this one. So 4 is there. 4 is there. Okay. We got 4. 5 is not there. Only 4. So this is our left hand side. Okay. For finding right hand side, this is our first equation. For finding right hand side, first you will find B intersection C. What are the common elements between B and C? So 4, 4 is there, 4 is there. Okay. 5 is not there, 9 is there, 9 is also common. So there. B intersection C. And now find with A intersection B intersection C, A intersection with this B intersection. Where is A? A is this one. A is this 4, 4 is there, yes, 4 is there, 4 is there, 4 is there. We will write 4, only 4 is there. From first and second we got right hand side equal, therefore we got A intersection B intersection C will be equal to A intersection B intersection C, and verified. Like this, you can do other questions also. Okay. Now, difference of two sets. Now we have to see what is the difference of two sets. Difference of sets. Difference means A minus. Let A and B be two sets. Let A and B be two sets. Be any two sets. Huh? Right hand here. Be any two sets. The difference means the set of all elements which belongs to A, which do not belongs to B. A minus B means difference means which belongs to A and does not belongs to B. Means we will remove the elements of B from A. A minus B means remove the elements of B from A. Okay. So the difference of A minus B, actually the difference of set A and B. That is, we are talking about A minus B. You can have B minus A also. A minus, no, A minus B is the set of is the set of elements set of elements set of elements which belongs to A and do not belongs to and do not belong to B. Means from A set it is denoted by a symbol minus. So A minus B is the set of all elements X such that X belongs to A and X does not belong to B. That means we have to remove the elements of B from set A. We have to remove the element. And similarly, if it is B minus A, so B from B you have to remove the elements of A. So here X belongs to B and X does not belong to A. All elements should be removed. So in Venn diagram, for example, A has an element 1, 2, 3, and B has element 2, 3. So if we have to find A minus B, means from A remove the elements of B 2, 3, only one is left. If we have to find B minus A from B, we have to remove the elements of A, that is 2, 3, so 5 will be left, nothing will left. Okay. So, and how to represent in the Venn diagram A minus B and B minus B, that is very important to understand Venn diagram. This is a Venn diagram to represent A minus B. First I will show you A minus B. So A minus B, always you have to draw the two sets like this one. They must have some common element. So A minus B. From A you have to remove the elements of B. This portion should be removed. So only this portion should be shaded. Got it? Because B portion is to be removed. So this is shading will show that what you want to show. You need to write the element. Only A minus B is this one. Similarly, B minus A minus. This is A minus B. You have to make B minus A, then B minus A. Now B minus A. Venn diagram. universal set, universal set. This is your universal set. I told you you could write universal set at some corner. This side also you can write somewhere u, big U. And now we are showing b minus a, b minus a. So draw one a and this one is b, a, b. From b you have to remove the elements of a. So this is you can write inside also a minus b, a minus b, and this will be the portion of b minus a and state this part. Shading should be very proper. It should not come out which of what we should do. And these circles you do not draw rough circles. You can use compass to draw the circle. Okay. So this is the way of denoting the things or uh, some. Suppose you have to draw the Venn diagram on the some given conditions, you can do it. Then we have disjoint set, complement of a set, De Morgan's theorem, and then application of theory. That will be the end. This is a very vast chapter. So that's all for today.